All right, so we're gonna look at temperature converter. It does say write pseudocode, but oh, look at here, I gave it to you. So here's your to do in pseudocode. So if I already give it to you, you don't have to redo it again. Oh, I can't, this is like the whole solution almost, isn't it?
There's a couple things you have to add.
Yeah, I made it way too easy, but at the beginning, there's nothing wrong with that. It'll get harder as we go. I'm sure you believe that, right? You know it's gonna happen. All right, so let me go up here and find my place that I've stored everything. I'm gonna go into my Python in week 3. I'm going to right click, show properties, hopefully by now in the 3rd week. You can do this fairly good. Temp converter. Apply. There we are, empty program. So as I am working on these kinds of things, if there's a formula I have to convert, I'll copy it from wherever, or if I looked it up in the internet. For example, I know that I'm gonna have to get input. I'm gonna have to get input from the user because that's pretty much how our programs are almost always gonna start with input from the user. Oh, I need temperature and what are we converting? Fahrenheit to Celsius or the other way around?
Both.
Oh, man. So what's coming in though? Oh, we have to do a menu. Well, when you're solving a problem that has more than one part, what do? You pick one and solve that one, then you solve the other one. Yeah. So I'm gonna solve the, let's see. Oh, I need a comment here. Let's see here. There's my comment thing. So I'm going to say get temperature from user. And we aren't going to specify whether it's Fahrenheit or Celsius because they get to pick that in the menu, right? Or do they? What do I say? Oh, okay. Let's see my thing where I ran it. Oh, okay. So then you know which way you're going. Okay, so I'm going to start with Fahrenheit to Celsius. And then I'll add the menu in later. So get Fahrenheit temperature from user. Fahrenheit temp from user, right? You don't have to do everything all at once. We're just gonna do little parts. And then I want my formula that I'm sure I just copied it from the web somewhere. I found it. There it is. Let's put that in here. I put it in as a comment, because then I know what the formula is supposed to be. So as I'm working on these things, I try to put them all in the program so I don't have to keep looking back and forth. So this is the wrong one, isn't it? Because this is getting Celsius from the user. Okay, so let's just change this. We'll convert from Celsius to Fahrenheit since that's the one I grabbed. There. We'll get Celsius from the user. I'm not going to do the menu yet. I'm just going to go through and do the conversion first. So we need a temp. And I'm going to do this C so that I know this is a Celsius or centigrade temperature. Is it fine to do things like this? Yeah, you could put the whole thing as temp Celsius too. But then when I do Fahrenheit, I'm going to do temp F. You know, it kind of makes sense, doesn't it? Yeah, we'll go with it. So then I'm going to get input from the user. Whoops. As I get input from the user, I have to have 2 separate input statements. The menu is going to determine which of those we go to. So far, so good?
Sure.
So we're going to enter Fahrenheit, which I had a student tell me they hated temperature conversion programs because they could never spell Fahrenheit.
Into,
Did I spell it wrong?
no, Celsius.
Excuse me?
It should be Celsius.
No, you're right. So I had my spelling story and it was for the wrong one. But she did not like spelling Fahrenheit. Thank you, Hope. What kind of a number? Remember, everything coming in as a string. What do we do here?
No.
So we have to convert it. Otherwise Python is going to complain. It's kind of a whiny program. Now, there's our formula. Which that actually should be down here, shouldn't it? Because this is input. here we're converting. So what did I do with it? Uh-oh, I deleted it accidentally. There we go. There it goes. So we are converting. So this is another to do. Do. We're converting. This is our conversion formula. In math, you use single letters. In programming, you try to be very descriptive. So we would do temp F to be consistent with what we did before. And then we start putting in our formula. Now, in the order of precedence, what happens first? And before you answer that question, let me find the order of precedence, or PDMES is the shortcut. Parentheses, exponents, multiplication, division, addition, and subtraction. PEMDAS, that's it, PEMDAS. So if we don't put parentheses in, this is the order it goes in. If you put parentheses in, there is no doubt what order things go in, because with order of operations, you start from the middle, the inside, and work your way out. Which that's a math thing. So here, our division is going to happen first, isn't it? Well, let's start working with this. So we're going to put a parenthesis. This part's going to be the same. We're going to do 9.0 divided by 5.0. And according to the rules of precedence, we multiply that by temp C. Oh, there it is. I have missed an underscore. However, what if you didn't know the order of precedence and you weren't sure what this did? How could we be more explicit and say, this is what I want to happen first? I want the division to happen first. What would I do here? Parentheses rule all the time. Parentheses top everything. So if I want to make sure that someone looking at the code knows this operation is happening first, I put this little part inside, even though at the order of precedence, it's going to go boop, boop, boop. Now you know this is going to happen first, then this is going to happen. Does that make sense? And you always have to have surrounding parentheses. You always have to match. The next thing in my formula is plus 32.0. Well, would we have to use a parenthesis at this point to make it the point obvious? No, because we're working our way from the middle out, and this is all that's left. We could put a parenthesis around it, but it's really not necessary. We already know that we're going to divide first, then multiply, then add. It says, ooh, we want to display it with a degree symbol. Oh, now we're getting fancy. You can either copy it from the PDF, or I'm going to do that. There is actually a website dedicated for copying the degree symbol. Who knew? It's called degreesymbol.net. It's like, that's what it does. There's this website just for the degree symbol. I have no idea why, but it's pretty funny. It goes through all the different ways to do degrees and all kinds of stuff. And if you click copy, you now have the degree symbol, because you can't type the degree symbol on your keyboard unless you know about the Alt key and all this stuff. Is it easier to copy it from here? Oh yeah. So I've copied it. I'm just going to put it in here so I have it. There it is. Now I know my temperature Celsius. I know my temperature Fahrenheit. All I need at this point is a print statement, don't I? Am I done with my program? Yeah. I've got input. I did my calculation. I need to display things. And now I've got my symbol. So I'm going to print this. And of course, we're always going to use F strings. Ooh, I need to put that in there manually and finish up with a parenthesis. So what did I do over here? I mean, there's a lot of ways to do this. I probably did something like, something Fahrenheit's equal to, oh yeah, okay, we'll do something like that. So we would do, what's our temp C? There we go. We'll just do temp C is, Celsius is temp F. Ah. Yeah, I got the wrong one. Is temp else Fahrenheit. And the degree symbol always goes, oh, I did the capital F, because that's why we see it on the weather reports, isn't it? So I'm gonna delete that and copy it in. Once you've copied something in your clipboard, it stays in the clipboard until you copy something else. So I want that there, and this is going to be a capital C, which is our shortcut for Celsius. There. And if you look at weather station things and, weather.com and all that, they have a little degree symbol in there. Very fancy. Doing Fahrenheit to Celsius, Celsius to Fahrenheit is the same pattern. A lot of things we do in programming and IT, we use patterns, because then you don't have to reinvent the wheel every time you're doing something. So we don't have to reinvent this wheel. We could copy and paste it, change it the other way around. Much easier than starting it all over again. I'm going to skip that part because one of the new things that we're working on is how do you do menus? Which while loops are really good at menus. Oh, we're not doing a while loop. Okay, we're in decisions, aren't we? Sorry, I was a week ahead. I have other classes that are in loops, but we're not doing loops. Okay. We're just doing if statements. Oh, that's too easy. So it says type 1 to convert Fahrenheit to Celsius. It says type 2 to convert to, whoops, I lost him. Oh, and then I give you the answer here. I'm just no fun at all, am I? All right. So you can only print one thing on an input line. And I don't know why I have a colon up here. That was an accident. Neither of them should have colons. I usually use colon to indicate, okay, here's the part where you're going to type in stuff. So these would both just be print statements, allowing the user to be able to know what to do. 1 for Fahrenheit to Celsius, 2 for Celsius to Fahrenheit. This is my input statement, where I get the information from the user. And I want it to either be 1 or 2. So what type of number is that? Is that a float or an integer? Yep. Because I want either 1 or 2. I don't want 1.5 because that's not going to help me at all. When I'm entering the temperature though, I only entered -40, but I could have entered -40.12345 because temperatures are usually in floats. Oh, and then 1 degree of precision. Oh, somebody has their microphone on and they're coughing at me. It's Joe. Mute you, Joe.
Oh, it's my brother. My bad.
Okay. Now I can mute you from this end because it's my class, my thing. All right. Or you could mute yourself. I know. All right. So let's look at how we structure this. So we do need to print. Oh dear. There we go. 1 C to F. I don't know if that's what the thing says, but it's close enough. Doesn't have to be exactly the same. We need to be able to figure it out no matter what I ask. F to C. Right? We want to let the user know what the number is asking us to do. If we had more choices, we'd add more print statements saying, okay, 1 is F, 2 is this, 3 is exit, whatever you have. So whenever you're doing a menu on the command line, you always print out the user choices first. Then they know what to type in. And we are going to use an input statement, right? And I had it do. Which temperature you want to convert from, I don't know. Convert. From, I don't know, it's pretty dumb, but I put this little guy here to again give them a hint as to they need to type in 1 or 2 or nothing's going to happen. I usually put a space so it doesn't, the typing isn't right up next to the colon. What kind of data do we want at this point? What's the data type, the type of information? You have a choice of string, float, or integer. Those are our 3 types of information we've worked with. Which one do I want? Actually, in Python, you could use a string or an integer because you can compare one letter to another. What do you think? Should we use integer or string?
String.
Okay. If we use a string, because we're not going to calculate with this, we can use a string or an integer. Here, we do have to have a float because we're calculating with it, but we're not adding or subtracting anything. So without anything telling it what to be, it's automatically a string. So I'll just call this menu choice maybe. Because that's what it is. They're going to choose what they want to do. Now, with what we've learned this week and the week before, what do we do here? How do we make the decision of what choice the person made?
If statements.
Yep, if menu choice equals, and it's not equals, it's if menu choice is the same as. If I put a 1 and we've asked for a string, it's not going to like me. So I have to tell Python it's a string by doing that. I have to put double quotes. Double quotes are how you tell Python in many languages, this is a string. Otherwise, this is an integer. It's a whole number. And you can't compare a string to an integer. You'll get an error. So far, so good? We've tested this to make sure it works. To get this inside the if statement in Python, it uses alignment, which is a lot easier than curly braces and stuff. So I tab each of these over. Now we know if we type in a 1, it's going to do this and move on. Right? If we type in 1, it's going to go from Celsius to Fahrenheit. If we type in 2, it's going to do the other way around, which we haven't written the code for it, but we're halfway done because we already have the shape of the code, the pattern that we're going to use. So if my choice is equal to 1, how do I decide if the choice is equal to 2? There's a couple ways to do it. Where would I do it? Where would I make my second menu choice?
Fahrenheit,
Excuse me?
at Fahrenheit. The next one, the next.
Oh,
choice.
yes. I guess what I'm saying is I have my if for this one right here. Where would I place my next decision piece? That's what I was trying to ask.
Oh.
Because here I've got this one. What if where do we put in the part that determines did they type in a 2? Take a look at your purchase price code. This is inside this decision structure. I go back and I can do LF, or I could do else, couldn't I? Right? Because we don't care what else they type as long as they don't type a 1. Or you could be explicit and say, this is another way to handle it. If. What is it called again? Menu choice. If menu choice is equal to, and we know we have to put double quotes around it, to, then we're gonna do something. Whoa, what's that pass business for? Is this a football game or what's going on here? Pass is something you put in when you're building a program and you don't want you're not gonna finish everything yet, but you want to see if what you have is working. So when you're doing a decision statement or any kind of a thing where there's indentation, pass means pay no attention to this. Because if they type in a 1, we're good. If they type in a 2, we're good. What if they don't type in either one? They type in something else. What is our remaining choice? How do we choose the choice? If they don't do 1 or 2, we have if, else if.
Or else.
Exactly, because there are no other options in this program. They either type in 1, they type in 2. If they type in anything else, they failed. Or they're not going to get the program to work right. Because you can do it just else, because anything else they type in, you could have it do it that way. If you're in a menu system with more choices and you're doing a loop, this might be a better way to do it, because this is letting them know that they typed in the wrong thing. Please use a valid choice. And when we get to loops, which is our next chapter, we can ask repeatedly for conversions. And if they don't type in the right thing, we'll say, please use a valid choice. Then we'll go back to the beginning and allow them another chance. So either way would work fine. It's usually better to be more specific and let them know that they've made an invalid choice, that they need to try again. It's good to have programming that gives feedback to the user on, what they did and what they did wrong and how they can fix it the next time. Because when a user is using your program, they're learning your program. And we want to provide training along the way. And so error messages like this help the user to better understand how to use your program. So now we're on to one last thing, which I'm just going to introduce, and you don't have to worry about it. If I type in oh, it's not going to work. Okay, never mind. If I type in a 2, there's nothing. It just passes and it keeps going. We haven't built the code. If I type in something else, it's usually a valid choice. So if you can imagine this looping around and coming back, and I think I'll just go ahead and put in a quick loop. So we'll do the same thing, but we'll have a loop in it. Oh, it's supposed to be capital T. And I actually need another choice that allows me to exit it. I'm only just demonstrating a loop. So a while loop it loops, it goes and goes and goes. It tests to see if the loop is true. Well, it's always going to be true. We'll work on that next week. I just wanted to show what your error handling does for the user. So I type in 1. I can make my conversion. Oh, but we're entering Celsius again. I needed to put my loop somewhere else, didn't I? Just a minute. I'm not demonstrating what I want to demonstrate. My loop needs to be up here. There. So don't worry about the loop. I'm just showing how the user feedback can help. All right, enter Celsius, 25. Ooh, 25 is pretty warm. I can do 2. And we'll have 25. There we go. If I type in something else, it says, please use a valid choice. It kicks you back to the menu again. Do you have to do that with this program? No. I was just going a little bit further to show how a menu can work in this type of a program. Do we use command line programs much anymore? When was the last time you ran a program that ran like this? Probably never. But building a graphical user interface is way more complicated than you want to get into at the beginning of a programming class. So this is very simple interface, the command line interface. The other type of interface, the graphical interface, is called GUI, graphical user interface, and that's what we're used to interacting with. But when you're beginning, you have to start out with the training wheels. And back in the day, I was on the internet back when everything looked like this, and we're dialing in with modems. So yes, that makes me a fossil. And we had to also power our computers with steam because, you know, we didn't have electricity everywhere at that point. So we had to throw in the cords of wood into the stone to develop enough steam to get our computers to work. Okay, well, my humor is wasted on this group. Because you couldn't get a power plug to go out to your Conestoga wagon, right?